What's up everybody, my name is Takuma Matsui here with 343 Labs in New York City. Today we're going to be continuing our adventure on modular synthesis patching, and in this video specifically we're going to be walking through some concepts relating to modulation or moving things over time. As with last time, you can follow along exactly what I'm doing using the patch in the link below. Let's get started! In the last video, I exclusively used modules that are developed by VCV Rack. I want to expand our palette a little bit by using modules that are developed by developers outside of VCV Rack. To do this, I'm going to head on to Library, browse VCV Library, and here are the two brands that I'm going to be using. One is called Audible Instruments. This is a recreation of the Mutable Instruments brand that exists in the real world in Eurorack. And you can add these modules using the Add button. And once you add them, go back to VCV Rack, head on back to Library, and update VCV Rack. The second brand that I'm going to be using is called Volt, V-U-L-T, which also makes these awesome modules for VCV Rack. For this video, I'm only going to be using the modules that are free, but you can see that you can buy some other modules if you choose to do so. So let's head back to VCV Rack, and I'm going to start off with a review by building the subtractive voice from the last video. Again, I'm control clicking to add modules. Let's start off with MIDI to CV. I'm going to select my device, Arturia MIDI Lab, and let's designate a audio output with the Audio 2 module. I'm selecting multi-output device, but you can select your external headphones or your audio interface. Let's add our oscillator, a VCO, and I'm going to use one by Volt. Let's use Bleak. Again, we're going to connect our volt per octave to volt per octave. Let's also add a filter, VCF, for voltage controlled filter. And for this, I'm going to use a Audible Instrument one. I'm going to use this liquid filter and a VCA, our fader, and an ADSR envelope. Let's tidy this up. Again, gate output to gate input, our on and off switch, our envelope output to CV in of our VCA, the fader. And now let's connect the audio signals. Our VCA out to filter input. Again, I'm going to use a low pass output to VCA input, and VCA output into our audio to left mono channel input. We should be hearing some sounds now. Cool. So this video is all about modulation or moving these parameters over time. We did this a little bit in our last video using our ADSR envelope. I'm going to hold Command to create a new connection. And I'm going to pop this into our filter CV input. I'm going to close down the filter and let's hear what we get. Again, if we change the ADSR shape, you can see and hear that our envelope generator from our ADSR envelope is modulating or moving both our VCA, the loudness, and also our filter cutoff, the brightness of our patch. Let's add a second ADSR envelope. I'm going to zoom out using Command minus. Control click to add a ADSR. I'm going to disconnect what we just did. Take our envelope output, connect it back into our filter cutoff input. I'm going to open up the filter for a second just so that we can hear what's coming out of our VCO. Cool. If we move our wave parameter, I can hear the timbre changing dynamically as if we're scrolling through a wavetable or applying some sort of wave folding function. I'm going to modulate this parameter using this second envelope. And again, I'm going to turn up the modulation amount. Let's add one more source of modulation so that we can animate this patch a little bit more. For our second source of modulation, I'm going to be using an LFO, which stands for low frequency oscillator. Low frequency meaning it's below the range of human hearing, 20 Hz or less, and oscillator, again, it's creating continuous oscillations. I'm going to take my sine output from my LFO and connect it into the input of the scope. You can see that it's creating this up and down motion at 2 Hz, 2 times a second. I can make this LFO a little bit faster to 11 times a second. LFOs come in handy if you want to create continuous motion that happens whether or not I'm pressing on a keyboard or not. Let's disconnect this envelope from our filter and take our sine output from our LFO, connect it into our filter cutoff input. Here's what we get now. Again, if you've played around with any kind of hardware or software synths, LFOs are pretty standard. So let's do something a little bit more fun. I like the sound of this LFO speeding up and down. We can shape this LFO speed using this ADSR envelope that I have already. Let's create a new connection with command click. And I'm going to take this envelope output and connect it into my frequency modulation input of my LFO. Let's see what this does by connecting the LFO output to our scope. I'm going to turn up my modulation amount. Now we can see that this ADSR envelope is modulating or moving this LFO frequency over time. We can also control the amplitude or the intensity of this LFO by adding a second VCA. I'm going to disconnect this from the scope for a second. And I'm going to connect my LFO to my VCA input. So I want to use the second VCA, which is basically a fader, to control the intensity of this LFO. So let's add another connection from this ADSR envelope and connect this into my VCA CV input. And let's see what this output looks like. Cool. For our third modulation source, I want to explore audio rate modulation. Audio rate just means that the signal is within human hearing range. Right now, an LFO is playing at 1.388 Hz, but if we push this above 20 Hz, we should be able to hear this as an audible signal. To test this, let's create another LFO. I'm going to duplicate the one that I have. And for a second, let's just connect it into our output. Here's our sine output. Right now, this LFO is pushing out signal at 1.8833 Hz, which is too low to be heard. But if we push this up above 30 Hz, if you're wearing headphones, you can maybe hear this. 170 Hz. And back down outside of human hearing range. So this means that we can modulate any of these parameters so fast that we start to perceive a new pitch. Let's add a second VCO. I'm going to temporarily disconnect our VCO from our VCF and bring our second VCO in here. So I'm going to use this second VCO that I just created as the carrier or the actual pitch that we're going to be hearing. And I'm going to be using the bleak oscillator as the modulator so that we can move a parameter of this second VCO really fast. Because I want to hear signal coming out of this second VCO, I'm going to reconnect our volts per octave. And I'm going to take our sine output, this is the actual signal that we'll be hearing, and connect it into the input of our VCF. Let's take our bleak oscillator and connect it into the FM input of our audible VCO. And let's see what happens when I turn up the modulation amount. Cool, we're starting to hear new timbre. What's basically happening here is I'm taking the frequency of this VCO and moving it up and down really fast at audio rate. This is basically frequency modulation, or FM, and hence FM input. Now if we change some parameter about this first bleak oscillator, I like this movement. I'm going to modulate this with the same LFO that we just created. Cool. And let's also mess with the pitch of this modulator. I'm going to take the envelope output and connect it into the volts per octave. Since we're not really worried about creating audible pitch anymore, I'm just going to mess with this patch and see what comes out. Let's also modulate this resonance parameter with our ADSR. We can also use a square wave for our LFO and modulate the pulse width. So how long are each of our squares using an envelope? Why not? Before we end, let's clean this up a little bit. Because now this bleak oscillator isn't really generating sound, it's a modulator, I'm going to keep this on the second row here and keep our MIDI down here. Let's tidy this up. As we create larger and larger patches, it gets harder and harder to keep ourselves organized. The way that I organize myself is I keep all of my signal processing, so oscillators, filters, amplifiers, stuff that's making sound in one row, and always with signal moving from left to right. And then I keep my modulators elsewhere so that it's a little bit out of sight. So before we wrap up, let's do a quick review. First is an envelope generator, or an ADSR envelope. Envelope generators deals with singular events. It only goes when we tell it to go. In this case, we're sending a gate signal in. The second is the LFO, or the low frequency oscillator. LFOs are great for creating continuous movement. As you saw, we can interconnect LFOs and envelope generators to create interesting gestures. The third is audio rate modulation, signal that's so fast that it's within our hearing range. In this patch, we used audio rate signals to perform frequency modulation to create weird inharmonic sounds. This is just scratching the surface in terms of what we can do inside of Eurorack. I added some additional patches in the link below so that you can check out some other ways of utilizing modulation in your patch. I hope you found this video to be helpful. In our next video, we're going to be talking about sequencing, or making Eurorack count so that we can create rhythms and pulses and gestures that unfold over time. My name is Takuma Matsui here with 343 Labs in New York City. For more information on our courses in New York, Berlin, or online, check us out at 343labs.com. Thanks again for watching. See y'all next time.